I just want to let you know that today's lesson will be recorded, and if you don't want to be a part of the lesson or be recorded, your voice, use the chat feature, and you can send me a private chat, and I can answer your questions. But just wanted to make you aware that this is being recorded, and if you're not a willing participant, to just send me a nonverbal message. The rest of you or anyone else is more than welcome. I appreciate any input because I don't hear from many students these days. They just sit there quietly. Solving for, I don't like the word angle. Let's do inclined plane. How bad is my writing with this pen? Solving for horizontal and vertical components of a resultant on an inclined plane. And I spelled the word vertical wrong. Not a good start. I should start my recording now. Solving for horizontal and vertical components of a resultant on an inclined plane. That's what we're going to be doing here. The questions are going to say, if you see this question, it says, find the horizontal and vertical components of the force. So all these questions, I'm not going to write this every time, but every one of these problems that we do is going to be solving for the horizontal and vertical components of the force. And what the picture is going to look like, you're going to have an inclined plane, and you're going to have a force that is perpendicular to the plane. So let's just say R is equal to 150 newtons, and we're at an angle here of 40 degrees. We'll make it easy. So R is 150 newtons, and we're at an angle of 40 degrees. And we want to find the horizontal and vertical components of the force. Now, we draw a coordinate axis at the tail end. You can see we have our positive X, our negative Y. This is a fourth quadrant force. So we have our X component and our Y component of this resultant force. So this gives a vector triangle that looks like this. We want to find our X and our Y. How did I know that this angle right here was 40 degrees, that these angles are the same? If I come up here, right, this angle and this angle, if I draw out my geometry, right, this one's 50, that makes this one 40, which makes this one 50, because we're all at these right angles the whole way around here, right? So that one's 40. Oh my goodness, I'm not having a good day. Hold on, I got too much crap on this page. Oh, I can't stand these fours. 40. We know this is a right angle. So if we put a plane here, we want to find this angle up here. Right, that angle and that angle are the same. This is a 50-degree angle, not a 40-degree angle. Because that's 40 degrees there. I don't know why fours won't write on this pen. So this is a 50-degree angle. Sorry, I screwed that up. A 50-degree angle. So when we solve our vector triangle, sorry, I'm having major difficulties with this pen today. Drawing these freaking triangles is difficult. Oh my goodness. This angle's 50. This is R, which is 150. This is Rx. This is Ry. So Rx equals 150 cosine 50 which comes out to be 96.42. And then RY is 150 sine of 50. $114.91 negative. So those are the components that are vertical and horizontal. Just not my best effort there. So I'm gonna pick it up the rest of this broadcast. Let's try another one. That was pretty bad. I'm trying to get my screen a little bigger here. I don't know if I know how. There we go. Now I'll be able to see it better. So for this one, we'll try the same idea. We'll put an inclined plane here. And I'm going to put a force on it. This time we will go like this, 90 degrees. R is 600 tons. And we'll make this angle here 25. So our X component goes here. Our Y component goes here. This angle right here is going to be 65 degrees. Because this angle and this angle are similar, or alternate interior angles, I think they're called. So our X is 600 cosine 65. $253.57 tons. And our Y is 600 sine of 65. $543.78 tons. And both of these are in the first quadrant, so they are positive. Both are positive. So remember, this is vertical and horizontal components. Let's try another one. Right angle again. A is 52 pounds. And this angle here is, I don't know, what does that look like? 40 degrees. What I want you guys to do is to draw the components for this. See if you can solve this. Just what I did. And I'm going to go to that. It's hard for me to not screen share when I... We got AX, AY, and our angle is going to be 50. So AX equals 52 cosine 50. $33.43, and that's got to be negative. And AY equals 52 sine of 50. $39.83, and that's positive. Anybody need anything clarified on that one?
So how do you know where you put the AX and AY lines? Because the other ones you went through the like 90 degree. So I'm like kind of confused with that.
That's a good question. So whenever you have a vector, whatever your vector looks like, right, that would be first quadrant and this would be fourth quadrant. For when you're finding vertical and horizontal components, You start at the tail and you just draw your axis. You always start at the tail and draw your axis. So you can see here, there's the angle. So here's your X and your Y. Here's your angle. So here's your X and here's your Y. In this case, if I start here, you always start at the tail. You see it now?
Yes.
So this is vertical and horizontal. Let's try another one. Anybody else have questions or concerns about this problem? One more. So I'll go with red this time because that's what I got out. Oh, I didn't want to do that. Let's try something tricky. Here's our angle. We'll make this 20 degrees. At a right angle right there, and this will be called A again. I like A. 42 newtons. All of this. Again, we are now drawing from here, from the tail. You can see we're in the third quadrant, 70-degree angle. AX, AY. AX equals 42 cosine 70. -14.37 negative. Third quadrant's got to be negative. Notice how all my answers have signs and units. AY is 42 sine of 70. -39.47 negative. Anybody need clarification on that one? So again, one more time, that's vertical and horizontal. If it asks for vertical and horizontal, you've got to be aware of what the question is asking for. The next type of question is going to ask for parallel and perpendicular components to the force. So for this problem, we are looking for components that lie along and are perpendicular to the axis. So let me get a different color here. I'll show you what I mean. So if I go with red, so let's say I have an angle again, I'll make it 60 degrees. And now I have a force sorry, I don't like that. Straight up, vertical force. Now we have to find the components that are parallel and perpendicular. So if I get my black, remember what we did last time? We drew a coordinate axis. Well, this time our coordinate axis has shifted 60 degrees. So that's our perpendicular line. This is our parallel line. See how our coordinate axis has changed? Normally it looks, oh, well, that looks the same because of this crazy pen, but normally it's up and across. We've rotated it 60 degrees. So now we have, this is our positive X, and this is our positive Y. So this is a first quadrant force. And this angle here, we got to find out that angle. Well, we can make this, we can square this off. We know that's 30, that's 90. So if that's 30, this is 30, which makes this 30. All right, let's take a clearer picture of this, and we'll figure out how to do the components. This is the one that's tricky because you have to remember that it's parallel and perpendicular, and you have to redo your axis. Your axis shifts. So I'll start it in, let's go with green or light blue. little peaceful shade of blue. Start with an easy angle, 30 degrees, and we're gonna have a vertical force, straight up. So A is, we'll make the numbers easy, 100 newtons. And we wanna find our parallel, right? This is this parallel and perpendicular components. So we come over here, we go to the black, so I can draw it. Here's our parallel, here's our perpendicular. Which quadrant is this force in? Somebody, I'd appreciate some help here, if someone could help me.
Quadrant 2.
Quadrant 2, good. Whoever that was, good job. I can't tell. So the ghost person. So the quadrant 2, you see here's quadrant 1. This is quadrant 2, quadrant 3, quadrant 4. Erase those. Won't let me erase. There we go. Now we're erasing. So it's quadrant 2. We need to find this angle right here, because that's our force triangle. Here's AX. Here's AY. This is 30. That makes this 60. That makes this 30. That makes this 60. So our force triangle essentially looks like that. Second quadrant. So then we say AX equals 100 cosine 60. What's that, 0.86 or 86.60 or something? Or 50, sorry, X is 50. 50 newtons, and that's negative because it lies along the negative x-axis. And this is 86.60. All right, that takes a little bit more time to understand. So we're going to do some of these. Anybody have any questions on that before I clear it off? All right, just as I suspected. Let's try, I like to do these in lighter shades to start. Orange might be too light. We'll see what happens here. More of an amber color, I think. You know, in Fortnite, I thought the orange weapons were yellow for a long time until my daughter told me that the yellow weapons are the ultimate weapons. So that's what I know. In terms of my color theory, 25 degrees. That looks like 250. 25 degrees. And we'll make our force here. R is 1.5 tons. And our goal is to find the parallel and perpendicular components. I'm going to go to this black color again. Does anybody remember where I'm supposed to draw the axis? Just think to yourself. You don't have to say it out loud if you don't want to. Just think. All right, do we all think? At the tail. There's our parallel, so this is positive X. This is positive Y. What quadrant are we in? Quadrant 4. Oh my goodness, it's so bad. So our angle here will be 75 degrees. So we're going to have a force that looks like this. So Rx equals 1.5 cosine 75. 0.39 tons. And our y equals 1.5 sine of 75. $1.49 tons. Definitely not 75 degrees, is it? What's 75 plus 25, team?
100.
100. What are we trying to get to? 90. This is fun. I get questions, I answer them. So this is a 65-degree angle. Sorry about that. 65. 65. 65. This is so getting deleted right out of the thing. All right, 1.5. Oh, man. 0.63 is Rx. $1.36 is RY. Yuck, that was ugly. Questions there? Nobody? All right, let's try one at our seats to see how we can do back there in Zoom land. Oh boy. It's a vertical line. 20 degrees. 512 newtons. All right, that's 20 down there if it is really ugly looking. Find the parallel and perpendicular components of R. I'm not sure what that is. All right, so what we got here is our axis parallel and perpendicular. That puts us in the third quadrant. Here's our angle, our X, our Y. This is 70 degrees. So our X is 512 cosine 70. 175.11, and that's going to be negative. And our Y is 512 sine of 70. $481.12 newtons.
Aren't they both negative?
One is negative 2. I beat you almost. You almost got me. Negative 481.12. How'd we do on that? Good? I can't see. I got to put the thing up. Where'd it go? I got too much crap up here. All right, a lot of thumbs up. I like it. All right, now, next, we're going to try one more of these babies. Then we'll go on to the last type of problem. Let me see if I can do something more difficult here. Try to trick you a little. Let's say we're on a ceiling at an angle and we're pushing up on the ceiling at an angle. What are my parallel and perpendicular components? And 37 degrees, and R is 120 newtons. Find my my cursor. Here we are, first quadrant, it looks like to me. We got ourselves 60, yeah, I almost did it again, 57 degrees. Rx is 57, cosine 37.
Shouldn't it be 53?
53, very good. I was making sure you guys were paying attention. Well done. 53.
And wouldn't it be 120 cosine 53?
Yeah, I really butchered that, didn't I? Don't give a thumbs up to that answer. All right, so it's maybe I didn't write on top of each other down there. I'm having a better chance at this. 120 cosine 53. 72.22 positive. And then our y is 120 sine of 53. 95.84 newtons. They're both positive. Any questions there? All right, now the last type of problem we're going to look at here today. I call them a line of action problem because a resultant, right, any resultant has what we call a line of action, which is really hard to draw with this pen to get it on the line. But a line of action is an infinite extension of that resultant. So if we have like a line here, the line of action crosses the line of action that results and crosses that line at this point. So what we're going to be solving for in this set of problems are where the line of action of a resultant crosses or intersects an x-axis. So let us try one of these problems. If I have an object here and I have two forces acting on it, we'll say A is, I'll make the numbers easy, 10 newtons, B is 20 newtons. And I need to know how far away they are from point P. So this would be 1 meter, and we'll make this 1.5 meters. My goal in this problem, find R and where it crosses x-axis. And we call this x bar. X bar is where it crosses the x-axis. That's x bar. So it's a two-part problem. We got to find the resultant first, and then we got to find where the resultant crosses the x-axis. So I'm going to try to leave that up the whole time, which means I'm going to be erasing. Move this over as far as I can. All right, so we have two forces, and these two forces here intersect right here. And the resultant of these two forces act, oh boy, they act like so, right? That's the resultant of the two forces. So that's made up of A and B. If we extend this axis, or this x-axis here, the resultant's line of action crosses the x-axis at this point. So from here to here, that's x bar. We know that from here to here is 1.5 meters. So we have to find this distance, D, I'll call it. X bar is going to equal 1.5 plus D. Does everybody see that? right? If I color D a different color, maybe you'll see it better. This distance here is D. The distance from where the line of action crosses along that denominator. So X bar goes from here to here. So first thing we want to do is find the resultant. So we draw our vector triangle. We already have it drawn. R squared equals A squared plus B squared. R squared equals 10 squared plus 20 squared. R equals 22.36 newtons, and we can find our angle. Tan theta is 20 over 10. Theta equals 63.44. degrees. It's a 4, not a 9. So the first part of our answer, 22.36 newtons at an angle in the fourth quadrant of 63.44 degrees. That's what we did last time. So that's the first part of the problem. Half the problem is solved. We want to find where this resultant crosses the x-axis. So we're looking for X bar. So I'm going to have to erase all this so I have some more room to write. Is there anybody who has, speak now if you have a question regarding how I found the resultant?
Since it's in quadrant 4, shouldn't the y value be negative 63.44 degrees?
Well, see, I have the arrowhead drawn right here.
Yeah.
See right here, the arrowhead?
Yeah.
That's telling me it's in the fourth quadrant. Resultants are two-dimensional forces, so they're never going to be negative.
All right.
The only time you have a negative is on your component. Like this would have been negative 20, but I had this arrow drawn down, so that tells me that it's negative. I don't have to rewrite it.
All right.
So this quadrant tells me an acute angle in that quadrant.
All right.
Good question. Back to erasing. All right, so the second part says, where does it cross the x-axis? So you can see we have a little triangle right here. See that triangle? If I fill it all in. We know that this distance is 1 meter. This is our side D, and we know this angle right here, which is going to be the same as this angle, 63.44. So to find D, we can say tangent of theta is 1 over D, or the tangent of 63.44 equals 1 over D. D equals 1 over the tangent of 63.44, which is a half. So we come over here and say X bar equals 1.5 plus 0.5, 2 meters. That's how far R is away from our axis. And that's how you do a line of action problem. First you find the resultant, then you find the distance based on that triangle. It's kind of tricky. Anybody have any questions on that before I do another one? All right. Let's try a different one. Point P again. This time we'll have A 50 tons. B is 300 tons. This height is 4 meters. Oh boy, I'm just gonna stop doing problems with 4s in them. 4 meters. This distance here is 6 meters. So our goal is to find out how far away it's gonna be. Now, is it gonna be less than 6 or greater than 6? Think to yourself. If I come here and I draw this triangle, I'm gonna move this all over so I have more room. If I come in here and draw my triangle, right, these two meet here, and my triangle will be, oh boy, like this. There's my resultant. We know from here to here, that's 6 meters. So this time we're finding this distance here, and we're gonna have X bar is from there to there. So X bar equals 6 minus D. See if you can do this problem. It's a little trickier. Give it some time. We have our resultant first, so X, Y, oh my goodness, I screwed that up. And our angle, we are not sure of. So we got 350. So R squared equals 300 squared plus 50 squared. $304.14. And then we have our angle. Which is 80.58 degrees. So our resultant, 304.14 tons at an angle of 80.58 degrees. Anybody have anything to need clarified on that problem?
I got 80.54. Is that?
What I said 80.54. I just wrote 80.58 for some reason.
Okay.
Didn't I say 80.54? I'll have to check the tape. 80.54. Sorry about that. So that's the first part. I'm going to have to erase this because I don't have a ton of space here. Could have probably left the answer up. And then we want to find our angle. So this time we have this triangle. So this distance here, D, is going to equal this D up here. And our angle is 80.54 degrees. So tan of 80.54 is 4 over D. D equals 4 over tangent of 80.54. $28.27. That's not good. That can't be right. What did I screwed something up here. Hold on, I can't have done that right. There we go. That's more like it. 0.67 for D. It's like, wow. So the next bar equals 6 minus 0.67, 5.33 meters. That's the distance that the resultant crosses away from point P. So, anybody have any questions there?